Hi, I'm Brian Lapointe. I would like to present some information to you today on water quality issues surrounding the Cudjoe Regional Wastewater Treatment Plant. I'd like to thank my co-author, Don Maynard, for his contributions to the talk today. My talk today will focus on the science and legal issues as to why a deep well is needed at Cudjoe Key. I'd like to begin by giving a brief overview of the water quality issues facing the Florida Keys. Then I'll look at the numeric and narrative nutrient standards that apply to Cudjoe Basin. Then I'll share with you some of the observations and data I obtained in a survey of Cudjoe Basin in August. I'll then describe the geohydrology of the area and talk about how this will further impair the surface waters of Cudjoe Basin. And lastly, we'll look at several other points of Florida law that require a deep well in this situation. Many understand that there are very serious water quality issues facing the Florida Keys. The problem is land-based pollution, nutrient pollution in particular, that fuels eutrophication, the buildup of organic matter in our coastal waters. The organic matter comes from harmful algal blooms. These are both phytoplankton, single-celled algae, as well as the larger seaweeds or macroalgae that grow on the bottom. And some of these species of algae also produce toxins that can be problematic for human health. And as all this kind of algae and organic matter builds up with eutrophication, it leads to decreased dissolved oxygen in our coastal waters. All these ultimately lead to the loss of corals, seagrasses, and overall biodiversity. And of course, no habitat fish. So as we lose corals and seagrasses, we're losing our fisheries as well. And emerging diseases and mortalities in biota, we see that happening throughout our coastal waters. For example, elkhorn coral on our outer reefs that have been decimated due to this bacterium Serratia marrescens that's traceable to the human sewage right here in the Florida Keys. Obviously, all the above is having a negative impact on the economy of the Florida Keys, that's based largely on tourism as well as commercial fishing. I have studied water quality and nutrient pollution in the Florida Keys for over 30 years. Some of these projects were a collaboration with Monroe County back in the mid-1980s and early 1990s. And because of the work I was doing at that time on sewage and the problems of septic tanks in the Florida Keys, I was interviewed by Fred Ward, who wrote this article for National Geographic entitled "The Coral Reefs of Florida Are Imperiled." This was back in July of 1990, when I was quoted that nutrient pollution is pushing Florida's reefs beyond their ability to survive. Cleaning up the sewage in the Florida Keys would be a major step in the right direction. And of course, it was some years later that the governor and cabinet mandated central sewage collection and advanced waste treatment here in Monroe County. This slide provides the Florida Administrative Code narrative nutrient standard and reads that nutrients, in no case shall nutrient concentrations of a body of water be altered as to cause an imbalance in natural populations of aquatic flora or fauna. And of course, this is the standard that was used in the Everglades lawsuit, and it also pertains to this situation. As we'll see, we already have an imbalance of flora in Cudjoe Basin as a result of very, very high nitrogen concentrations from leachate from the landfill. In addition to the narrative standard, Florida has recently adopted numeric nutrient standards. And you can see these standards for two different areas of the lower Florida Keys. the Back Bay or Cudjoe Key area, and also what's termed the Back Shelf and pertains to Upper Harbor Key, as you can see on the map, close to the Content Keys. And this is an area where we've done some research recently that I'll be using today as comparative numbers later in the talk. But anyway, you can see the standards for total nitrogen, total phosphorus, and chlorophyll A for these two regions. And I've given those standards both in micromolar units as well as weight volume units. And also what I've shown here is also the ratio of nitrogen to phosphorus. You can see it's 61.6 in the Back Bay. That's based on the standards of total nitrogen, total phosphorus, and it's 46.9 at Upper Harbor Key in the Back Shelf area. Again, that's based on the standards, but you can see the higher value in the Back Bay at Cudjoe Key tells us that there's more nitrogen relative to phosphorus, and we use this ratio often to look at areas that are highly enriched with nitrogen. And in this case, we will see how this applies to Cudjoe Key, where we see a lot of nitrogen coming off the landfill in the form of leachate and stormwater runoff. Okay, here's some background information on the Cudjoe Regional Wastewater Treatment Plant. This system will service an area between Big Pine Key and Sugarloaf Key that includes about 9,060 equivalent dwelling units, or EDUs. The plant has been permitted for 4 shallow injection wells with a maximum daily discharge of 1.88 million gallons per day. And if we look at the bottom bullet, you can see the permitted effluent concentrations. And if we go to total nitrogen, one of the contaminants of concern here, you see that it's been permitted for an average of 3 milligrams per liter, but up to 6 milligrams per liter within a 24-hour period. Well, that total nitrogen average of 3 milligrams per liter is very, very high compared to the surface water standard in Cudjoe Basin that is less than 0.3 milligrams per liter. So that gives you some indication of how enriched this effluent will be, even though it is advanced waste treatment effluent. Scientific research published in peer-reviewed journals indicates that the shallow well injectate will travel quickly to surface waters of Cudjoe Basin and further degrade this already impaired water body. The karst geology of the Cudjoe area is pocketed with conduits and connections through the limestone. This is especially true of the deeper Key Largo limestone formation. The travel time of sewage effluent from shallow wells to surface waters will be hours to days, even if one such conduit reached by the injectate. And this is based on the work of John Paul and his colleagues at University of South Florida. I'll talk in more detail about in a minute. But even if no conduit is encountered, travel time from shallow wells to surface waters will be at maximum 3 months. And this is based on porous media calculations flow through Miami oolite using, for example, the Darcy equation. And also work that I did using a KV Associates groundwater flow meter that was calibrated and used in Miami oolite on Big Pine Key. And I'll talk in more detail about that as well. But regardless of the travel time, the nitrogen in the partially treated effluent at Cudjoe is not removed during the transport period and will enrich the surface water, causing further degradation of an already impaired water body. This slide shows a conduit in injection well 2 at a depth of about 83 feet or 25.5 meters. That 3-inch diameter conduit, that dark area located above the depth numbers, extends into the Key Largo limestone formation from the well. So this is one of those conduits that will allow rapid movement of the wastewater towards Cudjoe Basin. This slide summarizes the research of John Paul and his colleagues at the University of South Florida in their studies on the Saddlebunch Keys, where they found that these karst conduits allowed rapid movement of wastewater from shallow injection wells into surface waters of the lower Florida Keys. The study viral tracers of sewage contamination in a shallow injection well at the Saddlebunch Keys. The tracer was detected at a site most distant from the seed site, a channel that connected Sugarloaf Sound with the Atlantic Ocean. The rate of tracer migration from the injection well to this channel ranged from 66.8 to 141 meters per hour. And essentially these studies showed a rapid movement of wastewater in a southeasterly direction toward the offshore reef tract, with preferential movement through tidal channels. This slide summarizes research I did with Monroe County back in the 1980s that assessed the movement of septic tank plumes through shallow groundwaters and found that both tides and rainfall enhance groundwater flow through this Miami Oolite formation in the lower Florida Keys. We used a calibrated KV Associates Model 30 GeoFlow groundwater flow meter to make direct measurements of groundwater flow through Miami Oolite on Big Pine Key. Lateral groundwater flows increased about threefold during ebbing tide as a result of tidal pumping. You can see that top left graph, how the flow rate goes up quite dramatically as the tide falls, and this is due to the increasing head as that tide ebbs. Okay, the highest lateral flows were associated with rainfall events that caused transient increases in flows, and you can see that rainfall event in the bottom panel causing a surge in lateral water flow. Overall, the average groundwater flow through the porous Miami Oolite was about 1 meter a day, a value that's quite similar to the calculated estimate of about 3 feet per day based on the Darcy equation. Now, although some of the phosphorus from these septic tank plumes was removed by adsorption to the limestone, the nitrogen in the form of ammonium and nitrate quite freely through these groundwaters and discharged into the adjacent surface waters. Because the partially treated sewage injectate exiting the casing at around 80 feet depth will be into a saline environment, the freshwater injectate will undergo buoyant flow and rise to the surface. Now, these shallow wells, because of this, will change surface water chemistry in Cudjoe Basin. The injectate will increase the slope of the water table around the wells, causing an increase in the head. This will cause flow of water effluent towards Cudjoe Basin, and the gradient at the shallow well injection sites will cause movement of wastewater towards the basin within hours to months. This conceptual cross-section shows how conduit flow can provide transport from the open hole at the bottom of the shallow well upwards through these tunnels and caves into Cudjoe Basin on the order of hours to days. And of course, this is the mechanism that John Paul and his associates described for the movement of their viral tracers. In contrast to the previous slide that showed rapid conduit flow from the shallow wells, this slide provides a conceptual schematic of porous media flow, which is slower flow as this injectate coming out of the open hole migrates upward through buoyant flow through the Miami Oolitic limestone and offshore into Cudjoe Basin. The porous media flow calculations indicate a travel time for up 3 months to reach the surface water in this case. In reviewing monitor well data for the Cudjoe landfill, it is evident that there is already nitrogen contamination of the shallow groundwaters around the landfill, and that these groundwaters are flowing in a northwesterly direction towards Cudjoe Basin. This is the Langen March 2014 report on the left, showing the location of the 5 monitor wells that surround the landfill. And the data show that concentrations of nitrogen as high as 4 milligrams per liter occur in these wells, and many of these wells have 1 milligram per liter or more total nitrogen. Relatively low phosphorus, as I mentioned previously, a very high nitrogen to phosphorus ratio due to the high mobility of nitrogen in these limestone groundwaters. And you can see evidence of that in the photos on the right side, taken on the site at the Cudjoe landfill, showing that kind of yellowish green water. Some of this color is what we call yellow substance, or colored dissolved organic matter, CDOM for short. But obviously some of this could be algae blooming in the very high nitrogen water that we're looking at here. Okay, knowing that the shallow groundwaters on Cudjoe Key around the landfill were so enriched in nitrogen, and that these groundwaters were flowing north and northwest towards Cudjoe Basin, I felt it was important to actually go out by kayak and take a look at these receiving waters of Cudjoe Basin to see what type of ecosystem response there might be to this nitrogen enrichment. And these are 2 sites labeled 1 and 2 going from east to west that I went out and collected some water samples and also took some photos that I'd like to share with you right now. Again, this was sampled on August of 2014. This slide shows the analytical results for the water samples I collected at Site 1 and 2, and also our previous data from Upper Harbor Key, just as a reference to Cudjoe Basin. And the Site 1 and Site 2 data represent average values based on 2 replicate samples. And what we see very clearly are very high nitrogen concentrations at both Site 1 and Site 2, over 100 micromolar. The standard is about 17 micromolar, so we're talking roughly 6-fold higher than the Florida Administrative Code standard for nitrogen in the basin adjacent to the landfill facility. The chlorophyll A down below in green, you see it also is well above the Florida Administrative Code standard, roughly 5-fold higher. And the TDN concentrations in the Cudjoe effluent are to average 3 milligrams per liter total nitrogen, or about 214 micromolar, which again will add to the nitrogen that is already in this system, and obviously the system already exceeds the standards, so we have a real problem here. Here are some photographs I took at the study sites in Cudjoe Basin showing the ecosystem response to nitrogen enrichment. And what we're looking at, obviously, are very thick algal mats or algal blooms. This is a green alga, or a seaweed or macroalgae that we call Batophora. And this particular plant is known to respond to elevated nitrogen and form harmful algal blooms like this. Now, we don't know that this plant produces toxins, but because of its sheer excessive biomass that you can see here, you can see it's overgrowing and smothering all the native biota. And this is how excess nitrogen basically is driving down biological diversity and productivity in this system. Okay, here are some more photos up in and around the mangroves in Cudjoe Basin as compared to a reference site on Big Torch Key. And what you clearly see on Cudjoe is how the mangrove pneumatophores, these are the breathing organs of the black mangrove, have been overgrown by the Batophora algae. And that panel on the left shows the Batophora overgrowing the prop root of a red mangrove. All the prop roots were just covered with thick growths of Batophora. And we see the seagrass growing around those mangroves is Halidlee, which is a seagrass species that is more tolerant of polluted conditions. It can grow under lower light and higher nitrogen conditions, but it doesn't provide the same habitat and productivity as turtle grass or thalassia that we ordinarily would see in these communities, such as the bottom photo on the right in the Big Torch Basin. And you can see above that the very clean pneumatophores as well that lack these harmful algal blooms. We also know that high nitrogen is detrimental to seagrass health in general and especially to turtle grass. Again, as we did previously with the mangroves, here are some photos from Cudjoe Basin of the open seagrass areas, these soft bottom areas, compared to similar areas on Big Torch Key, our reference site. And you can see the extensive cover of the Batophora blooms, how they've kind of overgrown and fragmented the turtle grass that should be growing there in a meadow, as you see at the reference site on the right. And you can see the low density, kind of productivity turtle grass or thalassia. And we saw few, if any, fish in this area as well. And that's likely due to very low dissolved oxygen, hypoxia, and possibly even anoxia that you get under these algal mats, particularly at nighttime when you don't have photosynthesis. You can see again on the right in the reference site, this is what these bays should look like. They should have healthy, high productivity turtle grass and abundant fish, and you can actually see some fish swimming through these turtle grass beds in the bottom right panel. Considering the evidence I presented today indicating that the discharge from these shallow wells will cause or contribute to a violation of state water quality standards, this Florida statute applies. Quote, if it is demonstrated that a discharge, even if the discharge is otherwise in compliance with this subsection, will cause or contribute to a violation of state water quality standards, the department shall, 2, order the point or method of discharge changed. Considering the evidence that we already have high nitrogen conditions in chlorophyll A and the benthic seaweed blooms in Cudjoe Basin, this rule from the Florida Administrative Code also applies. Quote, particular consideration shall be given to the protection from further nutrient enrichment of waters which are presently high in nutrient concentrations or sensitive to further nutrient concentrations and sensitive to further nutrient loadings, end quote. This is another rule from Florida Administrative Code that also applies. Quote, pollution which causes or contributes to new violations of water quality standards or to continuation of existing violations is harmful to the waters of this state and shall not be allowed. Waters having water quality below the criteria established for them shall be protected and enhanced. Okay, I'm going to wrap up with this summary. Sewage injectate from shallow wells will impact surface waters within hours or days through conduit flow to months through porous media flow, and nitrogen as well as other contaminants will not be removed during groundwater transport. Wastewater contaminants including nitrogen, phosphorus, bacteria, viruses, and organic wastewater compounds, such as pharmaceuticals and hormones, will impact surrounding surface waters. Injectate will increase flow of contaminated groundwater at the wastewater treatment plant into Cudjoe Basin. Nitrogen chlorophyll A and the green macroalgal blooms are evidence of existing violations of water quality standards in Cudjoe Basin. Regulations prohibit any additional pollution. I would like to thank all of you for listening. Bye now.